Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 24th March 2023. The problem statement for today is remove and reverse. This problem is based on two-pointer algorithm, strings and arrays. Let's now open this problem to solve it. Let's go through and understand the given problem statement. The problem statement says, given a string S which consists of only lowercase English alphabets, you have to perform the below operations. If the string S contains any repeating characters, remove the first repeating characters and reverse the string, and again perform the above operation on the modified string. Otherwise, you stop. Then you have to find the final string. So so it is said that in input we will be given a string S that will consist of only the lowercase characters, and we need to find, that means if any character is there which is repeating, then we need to remove the first occurrence of it and we need to reverse the string, and this way we have to continue until we reach the final string. So for example, let's go through the given example here. S is equal to AB. Here the output is BA. In first operation, the first repeating character is A. After removing the first character, first character, the string S will become BAB because this A has been removed. After reversing also, it will remain the same. In the second operation, here it should be repeating only. So in the second operation, the first repeating character is B. After removing the first character, it becomes AB here. BAB was here. So since B is removed, so now the remaining string will be AB. After reversing the string, it becomes BA. Now the string does not contain any repeating characters, so we have to return this final string. So here what we will do here, we have to check the count of each character, and if the count is greater than 1, then we have to remove that character from that position, and then we need to reverse it. So I hope this example is clear. Let's go through the second example. Here it is given that input S is equal to D, that is 4 D's are here, so the output is D only, because here we can see here 4 number of D's are there. So either from left side or right side, if you keep on removing, then at last you will be left with only 1 D, and that can be said that that D is not having any more repeating characters in the given string. So I hope both these examples are clear. So what we will do to solve this problem, we will be using the logic of removing duplicates from the input string using two pointer and a hash map. The hash map used to keep track of the count of each character in the string, while the two pointer will be used to remove the duplicates. The approach which we will use here that will start from the left and the right pointers at the end of the string and move them towards each other, removing duplicates as they go. The direction of the pointer will be controlled by one forward variable that will be initially set to true, since we are starting from the left side. So when the left pointer is moving forward, that means that when the forward will be true, so the character at the left pointer is checked against the hash map to see if it has the count greater than 1. If it does, then the character is removed from the string and the count of the hash map is decremented. The right pointer is also moved one step back. The direction of the pointer movement is switched by setting forward to false. So initially we started with forward is equal to true, so we will set next time forward to false. If the count of the character is not greater than 1, then the left pointer is simply moved one step forward. Similarly, when the pointer will be pointing to the right pointer, then when the right pointer is moved backward, the character at the right pointer is checked against the hash map in the similar way which we will check for the left side, that if the count is greater than 1. If it does, then the character is removed from the string and the count in the hash map is decremented. The direction of the pointer movement is switched by setting forward to true. If the count of the character is not greater than 1, the right pointer will simply move one step backward. Then this we will continue. Then the two pointers will continue moving towards each other until they cross. At this point, the resulting string may need to be reversed depending on the direction of the pointer movement when the pointers crossed each other. If the forward is true, then the resulting string is written as it is. If the forward is false, then we need to reverse the string and we have to return that one. So whatever the approach which I have just explained, let's see through the example. So suppose we have taken this the given input string only AB. So here, so first we will count the number of characters in each of them. So this char count will have A as this will have A and B as the component here, and the count of each is against them. So A is 2 here and B is 2 here. So initially we will point left to 0 and right to 3. That means we are maintaining 2 pointers here, and the forward will be true. So now we will check. Initially we will check. Since the forward is true, we will check with the left pointer. We will check if the char count dot get this string dot caret of left. So left was pointing to A. So here we will get char count dot get A if it is greater than 1. Here the count is greater than 1 because it is 2. So 2 is greater than 1. So what we will do? We will delete that character. So we will delete this A. So the string will become BAB. Okay. And we will decrement the value of the right pointer. So the see we have removed one character, so one character has to be decremented so that count remains same. And now we will change the direction. We will change the value of the forward from true to false. So the purpose of changing from true to false is to now it will start checking from the right pointer, from the right end. So now we will check if this char count dot get of string dot caret of right. So here earlier right was 3, but after update it became 2. So we'll check if the right of 2 is greater than 1. So here it is B. So count of B is 2. So 2 is greater than 1. Then what we'll do? We will delete one character from the right. Okay, so the string will become BA. Then we update the right pointer and switch the direction of the pointer movement. So after this, the left pointer will be at 0 only, right pointer will be at 1, and the string will be BA, and it will be pointing to the forward direction. So now what will happen? Now we will start moving from the left again. We'll check if B is having whether that value at the 0th index is having the count greater than 1. But the remaining string is this only, and after each deletion, if the way I told in approach, they will keep decrementing the value in the char count. So here it will finally say the substring is BA and the count of A and B is 1 only. So since it is not having the count greater than 1, they will simply increment the value of left by 1. That means left plus. So again we will check. We'll move forward. Now it will be pointing to A. Now we'll check whether the count of A is greater than 1 or not. So again, we can see the count of A is 1 only. It is not greater than 1. So again it will move forward. So it will be again do left plus. So here then now the left value will become 2 and right is still pointing to 1. So now we can see that both the pointers have crossed each other. And since it is still pointing to the forward direction, then in this case we will not reverse the string. If in case the forward direction is pointing to false, that in that case only we will reverse the string. If it is pointing to the forward direction, then we will not reverse the string. I hope this is clear. The reason for not reversing the string after each removal of character, see, only we are taking this part only at the end. That's why I'm explaining the reason. The reason for not removing the string after each removal of the character is to reduce the number of operations and improve the overall efficiency of the algorithm. Reverse the string after each removal would require some additional time and space complexity and is not necessary since the final string only needs to be removed. needs to be reversed if the pointer cross each other. I hope this given example, this approach, everything is clear. So we'll write our code here. Just to save time, I had already prepared the solution. I'll just paste it here. So here, all the approach, the complete approach which I have discussed so far, that only I have done it here. So first we are creating the hash map to store the count of each character in the string, and we are populating that char count. Initially we are taking that by default the value is 0. If it is present, then we will get that one and do the increment of 1, increment by 1. So suppose if any character is already present, then it will get the count of it and increment by 1. If the character is not present, then we will get the count as 0, default count as 0, and we will increment by 1. So even for the first insertion, the count will be 1 only. Then we are creating a string builder for the input string. Then here we are defining the 2 pointers to remove duplicate and this direction using the boolean flag. So now it is pointing to this left way is pointing to 0 and the right is pointing to length of the string -1. The example which I have shown here, in this one it was pointing to 0 and 3. The same thing is done there only. So here now what we are doing, we are checking in the char count if that character at that left pointer is greater than 1. If it is greater than 1, then we decrement the count by 1 in that char count. We delete that one and we update the right pointer and we change the direction. Okay, and if the count is not greater than 1, then we simply increment, which we did in the last phase where the count was 1 only. If it is pointing to in the reverse direction, then what we are doing the same thing for the right pointer. We are checking if the right pointer is pointing to the character which is having the count greater than 1. If it is true, then we decrement the count of that of the character which is pointer by right pointer. We delete that one and we reverse the direction. And after each operation, whether it is true or false, we decrement the right counter. So until this become false, that means after keep on incrementing and decrementing this one, when left pointer and right pointer cross each other, then we exit out of this loop and we'll check if it is pointing to still forward direction only, that means forward is true, then we return the string as it is. If it is pointing to the backward direction, then we reverse the string. So that's it it is done in this solution. So let me try compiling this code. So here we can see we have got correct output. Let's try submitting the solution. So here we can see we have got the correct solution here. That means all the test cases has been covered. So talking about the time complexity of this solution, it is big O of n, where n is the length of the input string. The first loop that constructs the map of the character count has a time complexity of big O of n, as it iterates over the string once and performs the constant time operation for each character. The second loop uses two pointer to iterate over the string from the both end, which we are using as left and right, and remove the duplicates. It also has a time complexity of big O of n. In the worst case, it will iterate over the entire string once. So overall time complexity will be big O of n plus big O of n. That is, overall it will be big O of n only. Okay, so so this was a Java solution. I have also prepared C++ solution for it upon the request of one viewer. So let me take that. So here also the complete logic algorithm completely same here, but this is in C++. Here we are creating an order map. So that again the same thing, map for storing the char count. Then we are using string here, string to store the variable, two pointer left and right with that same boolean expression as forward direction. We are still comparing the same thing, left less than equal to right. the direction we are checking, and we are doing the same thing whatever we have discussed in the so far, but only the language is changed. That was in Java, this is in C++. Let me try compiling this solution. So even this is correct, so let's submit C++ solution. So here we can see even this solution of C++ coding, this is also correct. Yeah, so that's all in this video. I'll provide the link for this question in the description box. Please do check that. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.